Hey, I'm glad you're here. Whatever today brought you, the worries, the noise, the unfinished thoughts, you don't need any of that right now. Those things can wait. They'll be exactly where you left them tomorrow morning. I promise. Tonight, you don't have to figure anything out. You don't have to be productive or useful or ready for anything. You just have to be here. So if you want, let your shoulders drop a little. Let your breathing slow down. There's nowhere to be right now. Nowhere at all. And when you're ready, I'll tell you something wonderful about the stars. About how they were born, how they live, how they quietly burn for billions of years, long before us and long after. There's something very peaceful about that, I think. So let's go there together. No rush. We have all night. Look up for a moment, or just imagine it with your eyes closed. Imagine the ceiling above you slowly dissolving, and beyond it, the sky, dark and deep and impossibly full of light. On a clear night, away from the city, you can see about 2,000 stars with your bare eyes. Just 2,000. And yet, that's enough to make you feel very, very small. And somehow, strangely safe. Each one of those tiny points of light is a sun. Some of them are much smaller than ours. Some of them are so enormous that if you place them where our sun is, they would swallow Mercury, Venus, Earth, and Mars without even noticing. And all of them, every single one, is doing something extraordinary. Something that has been happening long before humans existed. Long before the Earth had oceans. Long before this solar system was anything more than a cloud of dust drifting through space. They are burning. Quietly, steadily, patiently, burning. When you look at a star tonight, you're not seeing it as it is right now. You're seeing it as it was, years ago, centuries ago, sometimes thousands of years ago. The light left that star long before you were born, and it has been traveling through the darkness ever since, just to reach your eyes on this particular night. There's something almost tender about that, don't you think? All that distance, all that time, and it still arrived. The closest star to Earth, after our own sun, is called Proxima Centauri. It's about 4 light years away. That means the light you would see from it tonight left that star 4 years ago. 4 years of traveling through complete, silent darkness. And it ends here, with you. Most stars you can see are much farther than that. Some of the fainter ones you can barely make out. The light from those stars began its journey thousands of years ago. Some of them may not even exist anymore. The star could have died, and we simply haven't received the news yet. The universe keeps its secrets for a long, long time. Have you ever wondered why stars seem to twinkle? It's not the stars themselves that flicker. They burn steadily with no interruption, no hesitation. What you're actually seeing is their light, trembling as it passes through the layers of our atmosphere. Tiny pockets of warm and cool air, shifting and swirling above you, bending the light just slightly as it comes through. In a way, the star isn't twinkling at all. It's perfectly still. It's our own sky that's dancing. Planets don't twinkle the way stars do, because planets are close enough that their light arrives in a small, steady disk rather than a single point. Stars are so far away that even through a telescope, they appear as nothing more than dots. All that distance, compressed into a single point of light. When astronomers observe stars from space, from above the atmosphere, the stars don't twinkle at all. They shine with a calm, unwavering steadiness, pure and silent, without any interference. That's what the universe looks like when nothing is in the way. Now, Let your body sink a little deeper into wherever you're resting. Feel the weight of it, the warmth. There's nothing you need to do right now. Let's talk about color. Most people think of stars as white or pale yellow, but stars come in colors, deep, rich, surprising colors. And their color tells you something important about them. It tells you how hot they are. The coolest stars glow red, a deep, dim, slow red, like embers at the edge of a fire. They are still burning, still alive, still going, just at a lower temperature. Red stars can be small and faint, lasting for trillions of years, longer than the current age of the universe. Then there are orange stars, a little hotter, a little brighter. Our own sun sits between orange and yellow, warm and steady, giving off a soft golden light. It has been burning for about 5 billion years, and it has roughly 5 billion more to go. White stars burn hotter still. And blue stars, the brightest, the most intense, burn at temperatures so extreme that the light shifts all the way to the blue end of the spectrum. Blue stars are the rarest, the most dramatic, and the most short-lived. A blue star might burn for only a few million years before it exhausts itself. In cosmic terms, that's barely a breath. Our sun, by comparison, is middle-aged, middle temperature, and wonderfully ordinary. And that ordinariness, that gentle, consistent warmth it has provided for billions of years, is the reason anything at all exists here, is the reason you exist, is the reason you're here tonight, drifting towards sleep. There's something quietly beautiful about being kept alive by a perfectly average star. In the night sky, if you know where to look, you can actually see some of these colors with your own eyes. The star Antares, in the constellation Scorpius, glows a deep, unmistakable red. The star Rigel in Orion shines blue-white, cold and brilliant. And Arcturus, one of the brightest stars in the northern sky, has a warm amber glow that people have been watching for thousands of years. Ancient sailors used Arcturus to navigate. It guided people across oceans. And tonight it's still up there, still burning, still orange, still steady. The sky holds so much history, and all of it is still happening. Before a star exists, there is only silence and a cloud, not a cloud like the ones above you, not soft or white or gentle. A nebula, which is what astronomers call these clouds, is an enormous region of gas and dust spread across light years of space, cold and dark and almost impossibly thin. If you could scoop up a handful of nebula, it would contain fewer particles than the air in this room. And yet, out of that almost nothing, something begins. Sometimes a shock wave passes through, the echo of a distant explosion, another star that died somewhere far away. Sometimes it's simply gravity, quietly doing what it always does, pulling things together very slowly over millions of years. Bit by bit, the gas begins to clump. The clump grows denser, and as it grows denser, it begins to collapse inward under its own weight. The pressure at the center builds. The temperature rises. This process takes millions of years. There is no hurry. The universe is patient in ways we can barely imagine. Deep inside the collapsing cloud, something is waking up. The temperature at the core climbs to millions of degrees. And then, at some precise, inevitable moment, something remarkable happens. Hydrogen atoms, pushed together with enough force, begin to fuse. They merge. They release energy. And that energy, that first flicker of nuclear fire, pushes outward against the gravity that's been pulling everything in. The collapse stops. A balance is found, and a star is born. It will hold that balance between the inward pull of gravity and the outward push of its own light for millions or billions, or in some cases, trillions of years. One of the most beautiful places in the known universe is the Eagle Nebula, a vast cloud of gas about 7,000 light-years from Earth. Inside it, there are structures called the Pillars of Creation. Tall, dark, towering columns of dust and gas, quietly sheltering new stars being born inside them. The Hubble Space Telescope photographed them in 1995, and the image became one of the most famous photographs ever taken. Columns of cloud, taller than any mountain, taller than any thought, with stars igniting quietly inside, hidden from view. And here's the strange part. By the time Hubble took that photograph, the Pillars of Creation had probably already been destroyed. A supernova, a stellar explosion in the same region, likely blasted them apart thousands of years ago. But because they are 7,000 light-years away, the light of their destruction hasn't reached us yet. We are still seeing them as they were, still beautiful, still intact. The universe is full of these quiet delays, these gentle gaps between what happened and what we know. It makes you wonder sometimes what else we're looking at that has already changed. What other stories are still traveling toward us through the dark? But that's a thought for another time. Right now, just let yourself breathe. In and out. Feel how simple that is, how automatic. Your body knows how to do this without being told. It's been doing it since the moment you arrived in the world. Stars don't have that luxury. They have to work for every moment of their existence. Every second of their light is earned. Every photon that reaches your eyes traveled a very long road to get here. You don't have to earn anything tonight. Just rest. Our sun travels alone. It moves through the galaxy with its family of planets, slowly in a wide orbit around the center of the Milky Way. But it has no companion star, no other sun sharing its path. This is actually somewhat unusual. More than half of all stars in the galaxy are part of binary systems, pairs of stars orbiting each other. Some orbit so closely that their outer layers almost touch, exchanging gas and material between them in long, slow streams. Others orbit at great distances, taking thousands of years to complete a single loop around their shared center. Imagine having a second sun, a slower one perhaps, a dimmer one, hanging in the sky not far from the first. The light would be different. The shadows would come from two directions. Sunsets would happen twice, or they would overlap, the colors layering on top of each other in ways we don't have words for. Some planets in binary systems receive light from both stars at once, then fall into the shadow of neither. A long, strange twilight between two suns finally setting. There are even triple star systems. 3 stars, all bound to each other by gravity, tracing complex paths that no simple equation can fully describe. The mathematics of 3 bodies in mutual orbit is one of the oldest unsolved problems in physics. You can calculate where 2 objects will be indefinitely into the future. But add a third, and the system becomes beautifully, irreducibly chaotic. 3 suns, dancing together in patterns too complex to predict. The closest star system to our own, Alpha Centauri, is actually a triple system. 2 stars orbit each other closely. Alpha Centauri A and B, similar in many ways to our own sun. And then, much farther out, a small red dwarf called Proxima Centauri traces a wide, slow orbit around both of them. Proxima is the closest star to our sun, about 4.24 light-years away, and it has at least 1 planet orbiting it, in the zone where liquid water might exist. a planet in the closest star system, possibly warm enough for water, possibly watching two brighter stars from a distance, the way we watch the moon. We don't know what's on that planet, if anything is there at all. But the fact that it exists, that it's right there, cosmically speaking, just next door, is one of the more quietly extraordinary things about where we find ourselves. Stars find each other. They pull toward one another across impossible distances. They fall into orbits together and spend billions of years in each other's company. There's something in that I find very settling. Gravity is a kind of loyalty. The universe binding things together, not because it decided to, but because that's simply what it does. It pulls, it holds, it keeps. You might be feeling the weight of your own body now, the pull of the bed or the couch or wherever you've settled in for the night. That weight, that pleasant heaviness, is gravity doing exactly what it has always done. The same force that holds binary stars in orbit is holding you gently to the Earth right now. You are not separate from any of this. You are held by the same universe that holds the stars. Let yourself be held. Not all stars are as patient as our sun. Some stars are born enormous, 10, 50, 100 times the mass of the sun. And the more massive a star is, the brighter it burns, and the faster it runs through its fuel. It's a strange kind of trade. More energy, more light, more presence in the sky, but a much shorter life. The most massive stars may burn for only a few million years before they exhaust themselves and collapse. In cosmic terms, they flash and disappear almost instantly. Our sun, by contrast, with its calm and measured pace, will last 10 billion years. A red dwarf, a small, cool, dim star, might burn for 1 trillion years. Long after the universe has changed beyond recognition, there will still be small red stars quietly glowing in the dark. The largest known stars are so vast that describing them in miles or kilometers stops making sense. So astronomers compare them to the sun. One of the largest ever measured is a star called UY Scuti. If you placed UY Scuti where our sun is, its surface would extend beyond the orbit of Jupiter. The Earth, this entire world, would be somewhere deep inside it, not at the surface, deep inside. And yet even UY Scuti is just a point of light in the sky. Distance does a remarkable job of humbling things. These giant stars are called supergiants. They live fast, burn intensely, and end dramatically. But while they're alive, they are some of the most luminous objects in the galaxy. A single supergiant can outshine our entire sun by 1,000,000 times or more. Imagine that. A single star so bright that it would cast sharp shadows on a moonless night, even from thousands of light years away. One of the brightest stars visible in our sky is called Rigel, a blue supergiant in the constellation Orion. It sits about 860 light years from Earth, and even at that distance, it shines brilliantly. If Rigel were as close to us as our own sun, the sky would never grow dark. The light would be so intense that life as we know it could not survive. Orion is one of the most recognized constellations in the world, visible from almost every inhabited place on Earth, watched by humans for tens of thousands of years. Different cultures gave it different names and different stories. Some saw a hunter, some saw a giant, some saw a canoe, some saw a group of ancestors returning home. The stars themselves didn't change. Only the stories did. And that's the thing about the night sky. It belongs to everyone equally. Every civilization that has ever existed has looked up at the same stars, has wondered, has told stories, has felt that particular kind of quiet that only comes when you're standing under something vast, You are part of that long chain of people who looked up, all the way back to the beginning. Let that thought settle over you, like something warm. You are not separate from all of that history. You are woven into it. Every time you look up, every time you wonder, every time you lie still in the dark and let your mind drift toward the sky. Like right now, the stars are still there, above the ceiling, above the clouds, above everything, burning quietly, enormous and ancient and completely indifferent to the passage of our days. And somehow, that indifference is one of the most peaceful things I know. Our sun travels alone. It moves through the galaxy with its family of planets, slowly in a wide orbit around the center of the Milky Way. But it has no companion star, no other sun sharing its path. This is actually somewhat unusual. More than half of all stars in the galaxy are part of binary systems, pairs of stars orbiting each other. Some orbit so closely that their outer layers almost touch, exchanging gas and material between them in long, slow streams. Others orbit at great distances, taking thousands of years to complete a single loop around their shared center. Imagine having a second sun, a slower one perhaps, a dimmer one, hanging in the sky not far from the first. The light would be different. The shadows would come from two directions. Sunsets would happen twice, or they would overlap, the colors layering on top of each other in ways we don't have words for. Some planets in binary systems receive light from both stars at once, then fall into the shadow of neither. A long, strange twilight between two suns finally setting. There are even triple star systems. 3 stars, all bound to each other by gravity, tracing complex paths that no simple equation can fully describe. The mathematics of 3 bodies in mutual orbit is one of the oldest unsolved problems in physics. You can calculate where 2 objects will be indefinitely into the future. But add a third, and the system becomes beautifully, irreducibly chaotic. 3 suns, dancing together in patterns too complex to predict. The closest star system to our own, Alpha Centauri, is actually a triple system. 2 stars orbit each other closely. Alpha Centauri A and B, similar in many ways to our own sun. And then, much farther out, a small red dwarf called Proxima Centauri traces a wide, slow orbit around both of them. Proxima is the closest star to our sun, about 4.24 light-years away, and it has at least 1 planet orbiting it, in the zone where liquid water might exist. A planet in the closest star system, possibly warm enough for water, possibly watching 2 brighter stars from a distance, the way we watch the moon. We don't know what's on that planet, if anything is there at all. But the fact that it exists, that it's right there, cosmically speaking, just next door, is one of the more quietly extraordinary things about where we find ourselves. Stars find each other. They pull toward one another, across impossible distances. They fall into orbits together and spend billions of years in each other's company. There's something in that I find very settling. Gravity is a kind of loyalty, the universe binding things together. Not because it decided to, but because that's simply what it does. It pulls, it holds, it keeps. You might be feeling the weight of your own body now, the pull of the bed, or the couch, or wherever you've settled in for the night. That weight, that pleasant heaviness, is gravity doing exactly what it has always done. The same force that holds binary stars in orbit is holding you gently to the Earth right now. You are not separate from any of this. You are held by the same universe that holds the stars. Let yourself be held. Inside a star, something almost impossible is happening every single second. At the core, where temperatures reach 15 million degrees or more, hydrogen atoms are being crushed together with such force that they stop being individual atoms entirely. They merge. They become something new, helium. And in the process, a tiny amount of mass disappears and becomes pure energy. This is nuclear fusion. And the amount of energy released from even a small amount of mass is staggering. A single teaspoon of material from the sun's core, if we could somehow bring it here and release its energy all at once, would be enough to power an entire city for years. The sun converts about 600 million tons of hydrogen into helium every single second. And it has been doing this for 4.6 billion years. And it is in no danger of running out anytime soon. That energy, born in the core, begins a slow, complicated journey toward the surface. It doesn't travel in a straight line. It bounces. It's absorbed and re-emitted countless times, drifting gradually outward through layers of dense plasma. This journey alone can take over 100,000 years. A photon of light born in the sun's core today will not reach the surface until long after every currently living human has died. It will not touch your face for 100,000 years. And then, once it reaches the surface, it crosses the 93 million miles between the sun and Earth in just 8 minutes. 100,000 years to cross the sun, 8 minutes to cross the rest. The universe has a strange relationship with time. Some things take forever. Some things happen in an instant. And somehow, both feel right. Stars don't produce their energy evenly or smoothly. On the surface, enormous storms churn constantly. Solar flares, vast explosions of plasma that extend hundreds of thousands of miles into space. Sunspots, cooler, darker regions on the surface, come and go in roughly 11-year cycles. Galileo was among the first to record sunspots systematically, tracking them across the face of the sun in the early 1600s. He watched them move day by day and realized the sun must be rotating. He was watching the surface of a star move. People have been watching the stars, really watching them, taking notes, drawing what they see, for thousands of years. Ancient Babylonian astronomers tracked planetary movements with extraordinary precision. Egyptian priests oriented their temples to catch the light of specific stars at specific times of year. Polynesian navigators crossed the Pacific by reading the sky the way you might read a map. Before compasses, before GPS, before anything mechanical at all, just people and the sky and the knowledge passed from hand to hand across generations. The stars were the original technology, the first thing humans used to find their way, and they still work. On a clear night, far from city lights, the sky is still enough to guide you. The stars haven't moved, not noticeably, not on a human timescale. They are where they have always been, reliable, patient, still burning. Whatever has shifted in your day, whatever moved or fell through or didn't go the way you hoped, the stars are the same as they were last night, the same as they'll be tomorrow night. There's a steadiness to them that nothing in ordinary life can quite replicate. Let that steadiness come into your breathing now. In, slowly, and out. You don't have to do anything. Just stay here. Stars age the way all things age. Slowly at first, then all at once. For most of a star's life, nothing seems to change. It burns steadily, holds its balance, keeps its color. From the outside, from here, it simply glows. Year after year, century after century. Apparently unchanged. But inside, something is quietly shifting. The hydrogen at the core, the fuel that has been burning for billions of years, is gradually being replaced by helium. And helium doesn't fuse the same way. It accumulates, sitting in the center like ash, while the remaining hydrogen burns in a shell around it. The core shrinks, the outer layers expand, and the star begins to change. A star like our Sun, toward the end of its life, will expand enormously, growing into what astronomers call a red giant. It will swell outward, cooling at its surface as it grows, turning from yellow-white to a deep, warm orange-red. Its outer edge will extend far beyond where it is now, possibly all the way to where Earth currently orbits. This won't happen for about 5 billion years. There is no need to worry about it tonight, but it will happen. Everything changes, eventually, even the stars. Some stars don't wait for old age to change. They pulse, they breathe. These are called variable stars, and they are one of the more quietly fascinating phenomena in the sky. A variable star doesn't burn at a constant brightness. It swells and contracts in a regular rhythm, brightening and dimming, like a slow heartbeat. One famous type is called a Cepheid variable. These stars pulse with extraordinary regularity, their cycle of brightness tied directly to how luminous they actually are. This made them into cosmic rulers. By measuring how fast a Cepheid pulses, astronomers can calculate how bright it truly is. And by comparing that to how bright it appears from Earth, they can determine exactly how far away it is. It was through Cepheid variables that we first learned the true scale of the universe. In the 1920s, an astronomer named Edwin Hubble used them to show that what astronomers had been calling spiral nebulae were actually entire galaxies, separate from our own, unimaginably distant, millions of light years away. The universe at that moment became much, much larger. There's a particular variable star called Mira, a red giant in the constellation Cetus, that swells and contracts over a period of about 332 days. At its brightest, it's easily visible to the naked eye. At its dimmest, you'd need a telescope to find it. And it has been doing this for thousands of years, watched and recorded and wondered at for centuries. The ancient astronomers who noticed Mira disappearing and returning must have found it deeply mysterious. A star that appears and vanishes and appears again, on a cycle almost but not quite matching the year. There was no explanation for it then. Just the observation and the wonder and the recording of what they saw. Sometimes that's enough. To notice something and let it be strange, without needing to resolve it immediately. The mind doesn't always need answers. Sometimes it just needs something beautiful to rest against. Rest against this, if you like. Somewhere in the constellation Cetus, a red giant is slowly pulsing, swelling outward, then drawing back in, like breathing, like sleep. 332 days per cycle, patient and steady and ancient, breathing along with it now, very slowly, in and out. There is a star in the shoulder of Orion that astronomers have been watching with particular attention for a very long time. Its name is Betelgeuse, and it is not long for this world, in cosmic terms at least. Betelgeuse is a red supergiant, one of the largest stars visible to the naked eye. If it were placed at the center of our solar system, its surface would extend somewhere between the orbits of Mars and Jupiter. Everything we know, Earth, the Moon, every spacecraft ever launched, would be inside it. It glows a deep, unmistakable amber red, even to the naked eye. You can find it on a winter night in the northern hemisphere. It's the bright star at the upper left of Orion, contrasting beautifully with the blue-white brightness of Rigel at the lower right. Two stars, one constellation, separated by vast distances in space, but appearing close together from here. Betelgeuse is a variable star too. It dims and brightens over irregular cycles, swelling and contracting like something restless. In late 2019, it dimmed dramatically, more than usual, and the astronomical world took notice. For a few months, people wondered if the great dimming was a sign that it was finally approaching its end. It wasn't. Not yet. Astronomers later concluded it had released a massive cloud of dust that temporarily obscured its light. Betelgeuse settled back to normal for now. But eventually, in the next 100,000 years or so, Betelgeuse will explode. It will become a supernova. And when it does, for a period of weeks or months, it will be visible in daylight. It may be bright enough to cast shadows at night. It will be one of the most spectacular events visible from Earth in all of human history, assuming humans are still here to see it. No one alive today will see it. No one we know, or will ever know, will see it. But someone, someday, looking up at what was once Orion's shoulder, will see it happen. And then Betelgeuse will be gone. After that explosion, what remains will either collapse into a neutron star or vanish into a black hole. The constellation Orion will be changed forever. A familiar pattern in the sky, one that every culture on Earth has named and storied and navigated by, will have a different shape. It's a strange thing to sit with. The sky feels permanent. It feels like something you can always return to. But it too is changing, just slowly enough that we don't notice. On the scale of a human life, the sky is fixed and reliable. On the scale of 10,000 years, stars shift positions as our solar system moves through the galaxy. On the scale of 100,000 years, some of the brightest stars we know today will have dimmed or disappeared. On the scale of billions of years, the entire night sky will be unrecognizable. But right now, for you, tonight, for your whole lifetime, and your children's lifetimes, and many lifetimes after, the sky is exactly as it has always been. Betelgeuse is still there in Orion's shoulder, still red, still breathing in its slow, uncertain way, still burning, still waiting. There's something in that waiting that feels almost tender. A star that has burned for millions of years, nearing its end, still visible on winter nights, still doing what it has always done, until the moment it doesn't. We are all, in some ways, waiting, burning as long as we can, giving off light while we have it. But tonight, no burning required, just rest. When a massive star collapses, something extraordinary can happen in the final moments. The outer layers of the star explode outward in a supernova, releasing more energy in a few seconds than our sun will release in its entire 10 billion year lifetime. The explosion is visible across entire galaxies. It seeds the surrounding space with atoms forged deep in the star's interior. But the core, the very center of what was once a star, doesn't explode. It collapses inward. Electrons and protons are crushed together so completely that they merge into neutrons. And then it stops. At a certain density, the physics of neutrons themselves push back against further collapse. What remains is a neutron star. A neutron star might contain 1.5 times the mass of our entire sun, compressed into a sphere about 20 kilometers across, the size of a city. Imagine the mass of a star, an object 1.4 million kilometers in diameter, compressed down to the size of a city. The density is so extreme that a single teaspoon of neutron star material would weigh over 1 billion tons on Earth. More than every building, every vehicle, every living thing on this planet combined, in a space smaller than your thumbnail. These objects exist. They are real. They are out there in the galaxy right now, and we have detected thousands of them. Many neutron stars spin rapidly. Some spin hundreds of times per second, faster than a kitchen blender on its highest setting. And as they spin, if their magnetic axis is tilted relative to their rotation axis, they emit beams of radio waves that sweep across space like lighthouse beams. When those beams happen to sweep across Earth, once per rotation, we detect a pulse. Regular, precise, extraordinarily reliable. These are called pulsars. The first pulsar was discovered in 1967 by a graduate student named Jocelyn Bell. She noticed a regular signal in her radio telescope data, a pulse every 1.3 seconds, with a precision that rivaled the best atomic clocks of the time. It was so regular, so artificial seeming, that her team initially nicknamed it LGM1. LGM stood for Little Green Men. They considered briefly that it might be a signal from an intelligent civilization. Then they found another one, and another, and eventually understood what they were really seeing: the heartbeat of a collapsed star, spinning in the dark. Some pulsars are so precise that they are used as cosmic clocks. By tracking the pulses of several pulsars simultaneously, astronomers can detect tiny distortions in space-time, the ripples left by colliding black holes billions of light years away. A dead star, spinning in the dark, so precise it can detect the echo of a collision a billion light years away. The universe is full of instruments we didn't build. Let that thought drift for a moment. The galaxy humming with its own rhythms, pulsars ticking like clocks, gravitational waves rippling outward from catastrophic collisions. All of it happening right now, whether we're watching or not. The universe doesn't need an audience. It doesn't perform. It simply is, in all its strangeness, completely indifferent to whether anyone is listening. But we are listening. Or we were, earlier tonight. And now, you can let the listening soften. You don't have to hold any of this carefully anymore. Let it all go loose. The pulsars will keep spinning. The neutron stars will keep their impossible density. Everything will still be there in the morning. Right now, just the weight of the blanket, the quiet of the room, the slow rhythm of your own breathing. That's enough. Not every star ends in an explosion. Most stars, the small and medium ones like our sun, end much more quietly. When a star like the sun exhausts its core hydrogen, it expands into a red giant, swelling outward, cooling at the surface, growing enormous. Then, over thousands of years, it begins to shed its outer layers. Those layers drift away into space in expanding shells of gas, glowing gently as the star's hot core ionizes them from within. These glowing shells are called planetary nebulae, a name that has nothing to do with planets, but was given by early astronomers who thought they looked like distant planets through their telescopes. Round and soft-edged and colored in blues and greens, they are among the most beautiful objects in the sky. The Ring Nebula in the constellation Lyra is a famous example, a perfect ring of glowing gas, about a light year across, with the dead core of the star still visible at its center. The Helix Nebula, sometimes called the Eye of God, looks like an enormous eye staring out from the dark, a tunnel of glowing gas extending nearly 3 light years long. And at the center of each one, a white dwarf. A white dwarf is what remains of the star's core after the outer layers have drifted away. It no longer fuses hydrogen. It no longer fuses anything. It simply glows, radiating the heat it accumulated over its lifetime very slowly into the surrounding space. A white dwarf the size of Earth, with a mass close to that of the Sun. Dense, but nothing like a neutron star. Hot, but cooling. Quiet, but still luminous. White dwarfs cool so slowly that the universe has not yet existed long enough for any to cool completely. The oldest white dwarfs we know of are still glowing faintly, somewhere between white and yellow in color, still warm after billions of years. Eventually, in trillions of years, they will cool enough to become what theorists call black dwarfs. Cold, dark, invisible remnants of stars. Inert and silent, drifting through the dark between galaxies. But no black dwarfs exist yet. The universe is not old enough. Everything that was ever a star is still, in some form, holding heat. There is something very calming about that. The universe does not let go of warmth easily. Our own sun, billions of years from now, will follow this same path. It will swell into a red giant, reaching outward past the inner planets, and then gently release its outer layers into space, leaving behind a white dwarf at the center, a dense, hot, slowly cooling ember. That ember will glow for longer than the current age of the universe. In some distant future, some unimaginable civilization might look at that faint point of light and see, if they know what they're looking at, the remains of the star that once warmed a small blue planet called Earth. It's a long story, a very long, slow, quiet story. And tonight, you are part of it, somewhere in the middle of it, in the warm, bright chapter, the part where stars are still burning and planets still have oceans, and there is still time to lie down and rest. The ending is very far away. For now, there is just this, the warmth of the room, the softness of wherever you're resting, the slow, patient rhythm of the universe, doing what it has always done, burning and cooling and glowing and drifting, on through the dark. Here is perhaps the most extraordinary thing about stars. Everything you are made of was made inside one. When the universe began, about 13.8 billion years ago, there were only 3 elements: hydrogen, helium, and a tiny trace of lithium. That was it. The entire periodic table did not yet exist. There was no carbon, no oxygen, no iron, no calcium, none of the atoms that make up your body, or this planet, or anything you have ever touched. All of those heavier elements were forged inside stars. Inside a star's core, under the extreme pressure and temperature of nuclear fusion, hydrogen becomes helium. As the star ages and its core contracts, the temperature rises further. Helium fuses into carbon and oxygen. Carbon fuses into neon and magnesium. In the most massive stars, this process continues, layer by layer, element by element, all the way up to iron. Iron is where fusion stops producing energy. Iron is the end of the line for stellar nucleosynthesis. But elements heavier than iron, silver, gold, iodine, uranium, require something even more dramatic. They are forged in supernovae, in the final moments of a massive star's collapse. Or they are created in the extraordinary violence of 2 neutron stars colliding, an event called a kilonova, which releases more heavy elements in a fraction of a second than our sun will produce in its lifetime. The gold in any ring you've ever worn was most likely made in a neutron star collision that happened billions of years ago, somewhere in the galaxy. Scattered through space when the collision's debris was ejected outward, eventually gathered into the cloud that became our solar system, eventually concentrated into the Earth, eventually mined, refined, shaped, and placed on someone's finger. The calcium in your bones was forged in a star. The iron in your blood, the iron that carries oxygen through your body right now, was made in the core of a massive star and scattered by its supernova explosion. The oxygen you breathe was fused from helium in a star's interior billions of years before Earth existed. You are not separate from the universe. You are not observing it from the outside. You are the universe looking at itself. The astronomer Carl Sagan put it simply: we are made of star stuff. The atoms in your body have been inside stars. They have been part of supernovae. They drifted through space for billions of years and eventually found their way into the cloud of gas and dust that became our solar system, and then into the Earth, and then into the molecules of life, and then into you. When you look up at the night sky, you are not looking at something distant and unrelated. You are looking at where you came from. The light of distant stars falls on your face because you and the stars share an origin. You are made of the same elements, forged in the same fires, scattered by the same explosions. The boundary between you and the cosmos is much thinner than it appears. In a very real sense, the universe did not create you and then leave you here. It became you, and through you, it is experiencing itself, feeling the warmth of a blanket, noticing the quiet of a late night, drifting slowly towards sleep. What a strange and beautiful thing to be. A brief arrangement of ancient atoms, temporarily gathered into this particular shape, lying in the dark, listening to the story of the stars. Your atoms were there at the beginning. They will be here at the end. Tonight, they are resting quietly inside you. Let them rest. Our sun is one star among roughly 200 to 400 billion stars in the Milky Way. Say that number slowly. 200 billion stars, at minimum. And the Milky Way is one galaxy among an estimated 2 trillion galaxies in the observable universe. These numbers don't ask to be held tightly. They ask to be held loosely, like something you catch a glimpse of from the corner of your eye. Not quite graspable, but real nonetheless. Let them wash over you rather than trying to contain them. Our sun sits about 26,000 light years from the center of the Milky Way. We are not at the center, and we are not at the edge. Somewhere in a quieter region, in one of the galaxy's spiral arms. A good neighborhood, as galaxies go. Far enough from the chaotic center, close enough to have access to the heavier elements that accumulated there over time. The Milky Way rotates. Our entire solar system orbits the galactic center at a speed of about 230 kilometers per second. Even at that speed, fast enough to circle Earth in under a minute, it takes about 225 million years to complete one full orbit. This is called a cosmic year or a galactic year. The last time our sun was in this same position in its orbit, dinosaurs had not yet appeared on Earth. The time before that, there was no complex animal life at all. The Milky Way has completed about 20 such orbits since it formed. On a clear dark night, far from artificial light, you can see the Milky Way as a soft band of light arching across the sky. What you're seeing is the combined glow of billions of stars, too numerous and too distant to resolve individually, all blended into that pale, hazy stripe. Our ancient ancestors had no electric light to wash it out. Every clear night, the Milky Way was simply there, bright enough to cast a faint shadow, bright enough to navigate by, bright enough to inspire story after story across every culture on Earth. The Greeks called it the Road of Milk. In some indigenous Australian traditions, the dark patches between the stars, the dark nebulae blocking the light of more distant stars, are themselves the meaningful figures, not the stars. A different kind of reading. The negative space as the subject. There is something in that I find very freeing. The idea that what's absent can have as much meaning as what's present. That the gaps, the silences, the dark between the light, these are not nothing. They are part of the picture. The silence in a room at night, the pause between one thought and the next, the moment before sleep comes. These are not empty. They are part of something larger. At the very center of the Milky Way, hidden behind thick clouds of gas and dust, there is a supermassive black hole. It's called Sagittarius A star, pronounced Sagittarius A star. It has a mass of about 4 million suns, compressed into a region smaller than our solar system. In 2022, astronomers released the first actual image of it, a ring of glowing gas surrounding the shadow of the black hole itself. A dark circle, outlined in light, 26,000 light-years away from where you're lying right now. At this distance, it has almost no effect on us. The gravity is undetectable from here. It sits at the center, quietly, as it has for billions of years. And we orbit it, slowly, as we have for as long as the sun has existed. Everything in the galaxy is moving. Stars drift relative to each other. Nebulae expand and contract. The galaxy itself is slowly approaching another galaxy, the Andromeda Galaxy, which will collide with the Milky Way in about 4.5 billion years. Not violently, not like a crash, more like two clouds of fog merging together slowly, the stars of each galaxy passing mostly through the spaces between each other. Everything is in motion, and yet from here, from tonight, from this particular arrangement of you and the room and the dark outside, it all feels still. That stillness is real too. It's just a matter of scale. At the scale of a quiet room, at the scale of a body growing still, at the scale of a mind releasing the day, everything is at rest. If you're still here, if you haven't drifted yet, that's all right. Some nights take longer than others. Some nights, the mind wants to linger a little, and there are still a few more things I want to tell you, softly, before we let the quiet take over completely. There are stars so far away that the light reaching us now left them before the Earth existed, before the sun ignited, before our solar system was anything at all. The photons arriving at our telescopes tonight have been traveling for over 4 billion years. They passed through empty space while the Earth was still molten, while the first oceans were forming, while the first life was beginning. Simple, microscopic, quiet. They kept traveling while fish evolved, and then things crawled onto land, and then forests grew, and then ice ages came and went, and then humans appeared and built fires and looked up. And now the light arrives. Tonight, the universe has a way of delivering things at exactly the right moment, even if the journey takes billions of years. There is a phenomenon called the cosmic microwave background radiation. It's the faint afterglow of the Big Bang, the oldest light in the universe, stretched and cooled over 13.8 billion years until it's now a uniform, almost imperceptible warmth that fills all of space in every direction. It is everywhere. Right now, passing through this room, through the walls, through you. The oldest light in existence, and you are bathed in it constantly without ever feeling it. The universe began with light, and that light is still here, diffuse and ancient and quiet, holding everything. I find that deeply comforting, that even the very beginning is still present in some form, still lingering, still touching everything that exists. There are stars in globular clusters, dense spherical collections of ancient stars that orbit the edges of galaxies, that are nearly as old as the universe itself. Some are 13 billion years old. They predate our galaxy. They predate most of what we see in the sky. These stars were burning when the universe was young, when there were no planets yet, no heavy elements, just hydrogen and helium fusing in the dark. And they are still burning now. Whatever they have witnessed, whatever has formed and dissolved and rearranged around them over those 13 billion years, they kept burning, patient and constant. There is something in that kind of endurance that goes beyond what words normally reach. Not resilience exactly, not stubbornness, just continuity, the simple, profound act of continuing. You don't have to be remarkable to be worth continuing. You just have to keep going, the way stars do, the way ancient light does, the way everything in this universe keeps moving forward, one moment at a time, through the vast and patient dark. Tonight, your one thing to continue is this: breathing, resting, letting the day recede. You've done enough, more than enough. Somewhere above you, past the ceiling, past the atmosphere, past everything, there are stars that have been burning for longer than the Earth has existed. They were there before your great-great-grandmother's great-great-grandmother was born. They will be there long after every name we know has been forgotten. And right now, in this particular moment of their very long lives, their light is passing over this part of the world, over this city, over this building, over you. You are being touched by ancient light, even now, even as you drift. Let it be the last thing you hold tonight. Not tightly, just a soft awareness of it, somewhere at the edge of your mind, as everything else quiets down. The stars are burning. You are resting. Both things are exactly as they should be. So, we've traveled a long way tonight. From the twinkling of starlight through the atmosphere, to the birth of stars inside nebulae, to the quiet, steady burning of our own sun, to the vast red giants and their slow, ancient pulses, to the extraordinary density of neutron stars, to the gentle fade-out of white dwarfs, to the atoms in your body that were forged inside stars billions of years before you existed. You carry the universe with you. You always have. If there's anything I hope you take into sleep tonight, not as a thought to hold, but as something to let go into, it's this: you are not small. You are not insignificant. You are the universe knowing itself. A brief, extraordinary arrangement of ancient matter, lying still in the dark, remembering where it came from. There is nothing you need to resolve tonight, nothing you need to carry. The stars will keep burning while you sleep. The galaxy will keep turning. Ancient light will keep crossing empty space, heading somewhere, always heading somewhere. And you will rest. Let your face relax. Let your hands go soft. Let the thoughts that are still moving slow down, one by one, like stars emerging as the sky darkens. First the brightest ones, then the dimmer ones, then just space and quiet. There's nothing left to figure out tonight. Tomorrow, the light will come back. The world will be there. You'll pick up whatever you set down. But right now, there is only the dark and the warmth and the soft knowledge that somewhere above you, the stars are doing what they have always done, burning quietly for you. Good night. Sleep well.